Okay, welcome everyone. My name is Cormac Hogan. I work for VMware, Storage Architect, and I'm here to talk to you today about virtual volumes, or VVols. I'm going to be joined by Nick Dyer, my good pal. Nick works for Nimble, and they're going to be one of our first partners to implement VVols whenever we decide that we're going to bring that out. Might be aware we've been talking about VVols since 2011, I think, was the first VMworld that we introduced VVols, and we've been doing tech previews ever since. This year is no different. We're still doing a tech preview, but hopefully if you're participating in the vSphere beta at the moment, you'll have a good idea. Which we can't talk about, exactly. You'll have a good idea of where we are with VVols. Suffice to say that we're hoping that the next major release of vSphere will have VVols included. So the plan is I'll give you a brief overview of our software-defined storage vision and where VVols fits into that. I won't take too long over it. And then I'm going to pass you off to Nick, and Nick is going to talk about an actual VVol implementation as done by Nimble Storage, so showing you where we think VVols is going to be quite a game changer in the storage space.
Yeah, certainly, and for storage vendors, this is the big thing, because typically storage with VMware has been not a challenge as such, but there's many different ways to skin the cat, I think it's probably fair to say. And this kind of levels the playing fields, but also it makes everything a lot more granular, a lot more software defined, which is brilliant. And it just makes everything a lot more user friendly, I think, as well.
We shall see. Absolutely.
But only if you have a good implementation, of course.
Indeed, indeed. So let's quickly go through the slides. There is a disclaimer about VVols. Obviously, we're talking about futures and so on and so forth. So this is the usual thing that gets put up in front of a presentation like this. But anyway, you get the idea. So software-defined data center. Very quickly, I try not to spend too much time on it, but there are four paradigms that we look at from a software-defined data center perspective. There's a compute, which we have pretty much covered with ESXi, and this is what we've been doing in virtualization for an awful long time. There's networking, the Nicira acquisition, the NSX. We're doing the virtualization of the networks. We've also had the dynamic ops acquisition, which we're now calling vCake or vCAC, depending on which side of the water you're from. That's the vCloud Automation Center. But of course, the one thing that we still have left to do is storage. Now, Nick is going to kill me for mentioning this, but vSAN, which came out earlier this year, is our first step towards doing software-defined storage. But now what we want to do is we want to extend that for all of our storage partners, and that's what VVols is going to do. And if you're familiar with vSAN, you'll see a lot of the same concepts, the same type of functionality that we have at vSAN. In vSAN, from a converged infrastructure perspective, we're going to bring the same type of look and feel, the same type of operations to the storage vendors as well. So what are the challenges we have today? Well, when we think about it, when you're trying to deploy your virtual machine, I won't say it's very much hit and miss, but you do have to spend an awful lot of time figuring out whether your virtual machine is being placed on storage that's appropriate for the applications in that virtual machine. So I know an awful lot of our customers who maintain these big long spreadsheets of data stores, lists of the capabilities that are against those data stores and which virtual machines are on those data stores. So it's a very administrative, intensive management overhead that you have associated with positioning virtual machines on the correct storage right now. So that's kind of what we're aiming towards. The other thing as well is that everything is sort of LUN-centric. And so you have capabilities associated with LUNs. It could be deduplication or snapshotting or compression or encryption or whatever those capabilities are. But the point is that you do have to make sure that that virtual machine, that the application in that virtual machine is going to that correct data store. So, the risk of repeating myself, that's certainly an overhead. The other big thing we have is how do you do service level agreements for storage? Now, it might be that you have a certain amount of capabilities or a certain amount of IOPS or whatever that a particular data store can offer you. And that might be fine for the first handful of virtual machines that you put on that data store. But then as you start to build up and put more and more VMs on it, your SLA goes out the window. And that's why we have tools like Storage I/O Control in vSphere, Storage DRS, to try and address those concerns. But really, it's very hard to do SLA on storage in the current model.
And let's be honest, this is why a lot of people have gone to NFS for storage provisioning within ESX, because it tries to make it easier. It's trying to move away from this complex model that we have within block storage. So this has been something that everyone's kind of known about for many, many years. And you've got storage DRS, like you say, storage IO control. You've also got the VAI thin provision and map and a lot of other things, and that's per data store kind of granular basis. Even if you were to restore data sets back, snapshotting, replication, cloning, you've still got to go through the data store layer to mount it, to bring it back, resignature, and then bring the data set that you need on top. So whilst VMFS is a great tool, it still gives us a few administrative overheads that we have to do versus what other systems can do.
Indeed. Yeah. So, as I said, everything is pretty much LUN-centric now. And so the whole point of VVols is to try and bring the VMDK to become a first-class citizen in the storage world. So rather than working at the LUN level or the volume level, actually come down and start working at the VMDK level. And that's essentially what VVols is. VVols is an instantiation of a VMDK object based on the requirements that you put around that particular VM, and we'll get into that in just a moment. So this is a very busy slide. I do apologize. There's an awful lot of, let's say, bits and pieces to this. But we're trying to give you the idea that with software-defined storage, it shouldn't actually matter what storage you're going to. What actually matters is what's the capabilities that that storage can offer you. So it could be the converged infrastructure like vSAN. It could certainly be SAN or NAS storage as like a Nimble, or more recently now we offer cloud storage as well from vCloud Air, the object storage there as well. But to be honest, it shouldn't matter where we provision our VM as long as the storage can meet the capabilities. So that's what we have this layer of data services in here. Just click through that a little bit. So these data services, they can come from various different places. They could be the capabilities that the storage array offers up. So for instance, it could be deduplication, or it could be compression, encryption, all those different types of services we typically associate with storage. Or they could come from an appliance. Maybe there's a flash acceleration appliance, or whatever the case may be. The point is, using the policy-driven control plane or policy-driven storage, what we do is we build a policy and we put the requirements of the virtual machine into that policy. We then push the policy all the way down to the storage array, and the storage array will instantiate a VMDK object or a VVol object based on the requirements that we put in the policy. So that's what it's all about essentially. It's having this policy-driven mechanism where we abstract away the storage and pool the storage as well, so we don't worry about carving up LUNs or volumes. We actually get the storage array to instantiate the storage object on our behalf when we push that policy down to the array. And that essentially is what VVols is all about. So there's a bunch of advantages associated with that when we look at it from a SAN or NAS storage array perspective. There's a few of these are self-explanatory, I guess, but one of the main things for me is the actual SLAs. We can now achieve SLAs because each virtual machine has its own storage object. So you can actually get service level agreements based on your virtual machine storage. The other thing as well is from a scalability perspective. Right now we're limited to 256 LUNs per ESXi host. From a VVol perspective, that goes completely out of the water. We can have many thousands of VVol objects presented to an ESXi host. So this is really just the last slide for me. It's just to show you how VVols is allowing software-defined storage to happen for our storage partners and their own arrays. So we have the whole thing like abstracting away the storage, being able to build policies, associating those policies with VMs, and then pushing them down with a bunch of capabilities, asking the array to instantiate that VMDK object for us. And so let me just quickly, again, per VM granularity, we're moving away from the LUN and volume model towards the VMDK model. The ability to offload data services using things like compression, the deduplication, encryption, and so on from the arrays. And then the policy-driven aspect as well, of course. And then finally, we're just moving away from this LUN object towards a VMDK or VVol object. So that's our software-defined storage vision. As I said, we've already sort of achieved that with vSAN. Now the next step is to achieve that for all our storage partners. And so Nick is going to talk to you about what Nimble have been doing up until now to implement there. So take it away.
Yeah, thanks, Cormac. So I think this is probably fair to say that this is probably one of the biggest things that VMware have done on storage for a very long time.
I mean, apart from vSAN,
well,
yes.
Of course. But this completely changes the way that storage providers have to present storage to VMware. So for us, it's not as simple as creating a data store and saying, put VMs on it. We've now got to manage multiple objects, multiple different policies, we've got to manage multiple different kind of instances, and ultimately we're going to have thousands of instances on our system, so we need to be able to scale a lot farther. So it is a lot of work for us as well as a lot of work for you. So to take you through a bit of a pitch about Nimble Storage, we are a technology vendor. We're built from the ground up with Flash in mind, but we're also built with the idea of having policies. So we actually fit really well with this whole message, because we've got a Flash optimized file system which ultimately sequentializes I/O with variable block sizes. So we've always had the ability to create a 4K block for VMware, but also an 8K block for SQL. We've also been able to have 32K for Exchange, so we can actually optimize ourselves for the application that we're running within the host. But the challenge has always been, how do we present that through to VMware? We've also got a deep data analytics engine which is called InfoSight, which allows us to do performance monitoring and trending and analysis of our technology. So what that means for us is we've broken the link between performance and capacity, so we can actually scale performance in our solutions without having to buy more drives. So it's a completely revolutionary platform, but the big thing about it, ultimately, is how we optimize reads and writes. So we are optimized with variable blocks, we actually do compression inline, and then we sequentialize I/O, and then we actually inline cache hot blocks of data within SSDs. So we're Flash optimized in that mind because we're not using Flash as a write cache. The other big thing about how we optimize reads is we service reads of random workloads through SSDs. And that allows us to then be able to compress, and it allows us to be able to share up data sets such as SQL Server, VDI instances for golden boot images, whatever else we may need. Essentially what it means is we can get over a 90% cache hit rate on SSDs because of the way that we actually handle our data. But the big thing that we do in our technology is all about snapshots, cloning, and replication. So we allow customers to take 1,000 snapshots per volume. We could take 10,000 snapshots per array. So we can do a lot of data sets, but then the challenge is, how do we take snapshots of a data store? If I've got SQL servers in my data store and I've got Exchange, what do I do? So typically I've always separated out data stores, and this has always been a bit of a challenge because I want to be able to isolate, or I want to be able to give SQL Server SLAs different to how my Exchange works, or differently to how my VDI platform works. So the major thing about what we do is, with our snapshot and replication technology, it allows customers to take lots and lots of snapshots, and these are actual stats pulled from our customer set, where over 30% of our customers for SQL, for example, take less than an hourly RPO for snapshots, and that's typically something unheard of in the storage industry. Now, that then again becomes a question of, do I do that to the VM? Do I do an RDM mapping? Do I do a data store mapping?
You don't want to do an RDM map.
Right. How does that work with SRM? If I want to use SRM with my replication, do I do it in guest or do I do VMDK?
Yeah.
So there's lots of things that we need to build into it, because a lot of our customers do use snapshots and replication as a primary data set for restoration and retention. So we need to be able to give customers the footprint to be able to restore back data sets whenever they need to, going back 90 days, 180 days. But if they have to go through VMFS, and they have to remount the data store and resignature the data store, then it's a lot of work that they have to do. Yeah. So the main thing about it is the consideration that everyone has to go through. So I've actually pulled this from our best practice guide for VMware. It's all about, where do I map the data sets? Yeah. Now I've worked for Equalogic, I've administered a NetApp array, and everyone has their own best practice. If I want to do, SQL, consistent snapshots for SQL or Exchange, I'm probably best off doing that through the VM. I want to do ingest iSCSI, I want to do VSS snapshots, but then restoring that back and rolling that back, I have to do more jumps in order to do so in the VM. But also, I actually have to do things such as fiddle around with SRM to try and make it work, because SRM doesn't understand guest-mounted volumes. I could do it through VMDK and do vCenter query snapshots, but the challenge with that, ultimately, is I'm only as granular as the data store, which is exactly what you've just gone through, Cormac. And then you've got the raw device mapping, which is, as you rightly say, you typically don't really want to go there. So the whole idea of the benefits for us is we can now start pushing our intelligence of our file system. We can now start pushing our snapshot integration, we can start pushing SQL integration, our block sizes, our compression, but also the thing's ability of caching data. I can now push that right through to a per VMDK level without having to worry about the data stores on the back end. So I can now replicate per VM to per VM without any kind of overheads, but I can now do per virtual machine restores. I can do per VMDK restores. I can roll back a SQL database without having to worry about what else is on my data store. Now the big thing about this as well is I'm now as granular as I want to be for an RPO and an RTO for SQL or for Exchange or for my PDI, which is brilliant. But it now allows us to push the optimization of our block sizes within to the VM. So I can now optimize a volume on the Nimble array to be an 8K volume for SQL Server, but I don't want to do things like caching on my log files, because log files are never really read back. So I can now push intelligence to say don't cache logs within VMware, and that will then come down to the actual Nimble array. And then I've got the deep data analytics of InfoSight, where I can actually monitor and quiesce and kind of poll everything that goes on. So it sounds great, but there needs to be a few things on the storage array level that we actually have to do to re-architect this stuff. So it's not as simple as just saying, here's a provider, away you go. We've actually had to completely redesign how our systems work on the back end. And to be fair, it's not just us, it's every vendor, right? Yes. So it's Dell, it's HP, it's NetApp, it's EMC.
Yep.
So everyone's having to put the same amount of work in. But I think we're actually positioned really well because our solutions are built with these granular performance policies and these granular block sizes in mind. Traditional storage vendors only work on a single block. So where if it's only a single block, I'm only as good as what that block size is. So what do we need for that? Well, first off, I need a VASA provider. That's one of the big things that we need to be able to inject within vCenter to give the array intelligence to actually understand what's going on. So that's one thing that we're really doing at the moment. We then have what's called a protocol endpoint, which is essentially the data plane where we have connectivity from the virtual center and the ESX hosts, which then connect to the array. Within the array, I have to create what's called a storage container. So I actually have to provision something which is kind of like a virtual pool or a container of some sort. It's not a volume, it's just like I guess you can think of it as like a provisioned amount of space that VMware knows it can use. It's probably the best way of doing it.
And for all intents and purposes, that storage container looks like a volume when it appears on in vSphere. So you will have your VMFS volumes, your NFS volumes, and going forward, you'll also have your VVol container visible as a storage object in vSphere as well.
Right. Yeah. So that's one of the things you have to do is you have to inject your storage container into it, and then it allows you to be presenting the VVols through it. But on our solution, we won't show that container as a volume. It will be something akin to like a virtual pool or a folder of some sort. And then what we do is whenever you provision a VMDK, you can actually then select profiles that you build for SQL Server, which allows you to build in snapshot retention, replication retention, block sizes, whatever you may need to do, it pushes it right into the VM. So I create a vDisk or a VMDK, I select the profile that I need, and then it just pulls through everything else within the array straight up to vCenter and the actual server itself. Now those VMDKs look exactly like virtual disks or volumes within the array. So you're now going to have a lot of volumes that you have to manage, and that's where I think a big challenge for a lot of vendors are going to be. How do we allow you to search? How do we allow you to categorize or kind of folder those kind of containers up? Because if you've got 100 VMs, each one has a CD and E drive, that's 300 volumes that you'll have on your array that you've got to be able to manage. So we'll have this management plane, which is the VASA provider, that allows us to inject the intelligence of the array within VMware. So that's the kind of plugin that you do, and we'll actually just inject that from the Nimble array itself. So you won't actually have to kind of drop anything into vCenter itself. You'll go to the Nimble array, you'll give it the IP address, you'll click submit, and we'll just inject everything for you. So there's nothing really else that you need to do there.
Well, that's interesting. So your VASA provider is actually on the controller, let's say?
That's right. So our VASA provider is actually in the array. Yeah. So all the customer has to do is go, here's my IP address, here's the username and password, and we just inject everything within the server. So we actually believe that we've got probably one of the most simplistic VVol implementations, because it's just a case of giving it the IP and we do everything else. Whereas on the other side of it, typically vendors will have to go into the hosts and inject everything else. Yes. So it allows us to inject in our capabilities. So we can advertise snapshots, we can advertise replication, compression, data matching and pattern matching, but also access control as well. The data plane is what allows us to be able to create these volumes. So the data plane is actually how we will configure and connect to the array, and actually how we will present those storage volumes and present them up to the server. So you'll have log volumes, or you'll have data volumes, or application volumes. So it allows us to be as granular as we want, or as simplistic as we want. We could just set it as everything is gold and just away we go. But this is where storage IO control and storage DRS and a lot of other things get rolled in, because I can now put policies on each individual application. So if I'm a storage guy, I can push that intelligence in VMware, so when my VMware guy goes to the application, I need X. And it inherits all the RPO, the RTO, and all the policies that I need that the storage team have already provisioned for me. So it makes it a lot easier, I think, ultimately.
The other interesting point as well is that when it comes to managing your multipathing, as you mentioned here, you only have to worry about the protocol endpoint, because every VVol that's at the back of that protocol endpoint intrinsically just ends up with the same multipathing, whether it's round robin or whether it's active or whatever, based on what you set up on the protocol endpoint. So it makes all that management much easier as well.
It certainly does. So hopefully you guys can all see actually how much of a change this is actually going to be, because it's a lot of work that we have to do, but it really does reap rewards in the end of it, because it just makes everything so much easier. So all those considerations that we had before about how we map storage, where it goes, is it in-guest, is it VMDK to RDM, that conversation is way out the window. So all I have to do now is inject the VASA provider, and then I can just go and configure anything else that I need to. But ultimately, if I've got a political kind of environment where my storage team and my VMware team are completely different guys, it allows me to kind of let the storage guys provision or tell me what I need, and I don't have to touch anything else, and I don't have to worry about what those guys are doing. I just create my VM with my SQL Server or Exchange, and I just kind of be done with it. So this was a lightning talk. We wanted to keep this short and sweet today. If you come to the Nimble booth, which is S316 in the Solutions Exchange, we are actually giving demos of this. So if you want to come along and actually see how all this works, we do like a little mini hands-on lab where you can actually go through everything and actually get your hands on it. If you're a Nimble partner, if you go to Nimble University, you can actually get this as well online. If you're a Nimble customer, we would happily give you demonstrations of that right now as well. Anything to add, Cormac?
No, that's it. Thanks a lot, Matt.
Thank you.